Hey class, we left off with 125 divided by 2 for problem 23b. So we would take 2 into 125. 2 goes into 12 6 times. 6 times 2 is 12. 12 minus 12 is 0. And we bring down our 5. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. And we have a remainder of 1. Now, this number in front of our remainder, which is our integer, will be the integer to our mixed number. It'll be 62. Our denominator will stay 2, and our remainder is our numerator. So our final answer is 62.5. Now we go to problem number 24. It says here, Joe has a truck which is 18.5 feet long, and his friend Mark has a car which is 13 2/3 feet long. How much longer is Joe's truck? So what we would do is we would do a subtraction problem. It would be 18.5. We could add the feet later in the problem. Minus 13 2/3. Now we have to find the common denominator. And what's good about this problem is our denominators, both our denominators are already prime. So we know in order to get the common denominator, we multiply them together because 2 is prime and 3 is prime. So we multiply them together and our common denominator is 6. So what I'm going to do is I'm going to give a little bit more space here. Put our equal sign. So we have 18 minus 13. And our denominators for both of these fractions would be 6. So we ask ourselves, comparing 2 to 3, what does 3 have that 2 does not? It has a 3. So we multiply the numerator and denominator by 3. Then we compare the 3 to the 2. What does 2 have that 3 does not? It has a 2. So we multiply numerator and denominator by 2. So 2 times 3 is 6. 1 times 3 is 3. 3 times 2 is 6, and 2 times 2 is 4. Now if you notice here, we cannot subtract these fractions because this bottom fraction is larger than the top fraction here. So we know we have to borrow 1 from this 18, and we will make that 17. So we carry this over. We have 17. Our denominator will still say 6. Minus 13. And our fraction here in the denominator, well, our second mixed number, the fraction, would still remain 4 or 6. Now we ask ourselves, since we borrowed 1 from here, to recognize borrowing 1 in our numerator, all we have to do is add the denominator and numerator together. 6 plus 3 is 9. So our numerator is 9. So we add 9 6 minus 4 6, which is 5 6. 17 minus 13 is 4, and it's feet. So it's 4 and 5 6 feet. Now we scroll down here to problem number 25. It says, based on a survey of 600 entering students, the following graph was created. Now the graph is down here. Now it asks us what fraction of the students intend to get an associate's degree. So what we need to do is this here. We want to get the fraction of students that want to get an associate's degree. Now we have 2/5, 3/20, 1/20, and 1/10. So we need to input this. So let me see, 2/5. We had 2/5, 1/10. Let me scroll back down here. We had 2/5, 1/10. We got 1/20 and 3/20. Okay, now they said what fraction of the students intend to get an associate's degree. So we would add up all of the people that are seeking the associate's degree, not the personal interest and not the certificate. So what we could do here is this here. Since this is all addition, let's take a look here. We have some like terms here with these 20s. So we could go ahead and combine that. So we had 2/5 plus 1/10 plus this would give us 4 over 20. Now, what we could do here is this here. We have 5, 10, and 20. We can find their least common denominator. So we have 5, 10, and also 20. We know 5 is prime, 10 will give us 2 and 5, and 20 will give us 2 2s and a 5. So now we look here. We have one set of 2s that match up. We count that once. Now each one of these have a 5, but we still will only count the 5 once. And what we have left over is another 2. So our least common denominator is 20. So what we need to do is this here. We need to say, first of all, since our least common denominator is 20, we could just compare everything to the 20 here. We could say basically, what does 20 have that the 5 does not? It has 4 more than the 5, so we could multiply this numerator and denominator by 4. Now we could compare the 10 to the 20. What does 20 have that 10 does not? And we could look here. It has an extra 2. So we'll multiply the numerator and denominator by 2. So now we will have 8 over 20 plus 2 over 20 plus 4 over 20. So when we add all of them together, that would give us 14 over 20. Now we could do the prime factorization of our numerator and denominator. We have 2 times 7. We know the prime factorization of 20 is 2 2s and a 5. These two simplify out, and we will have 7/10. So that is the fraction of students who intend to get an associate's degree. Now we go to B here. It says how many of the students intend to get an associate's degree. So what they want is the actual raw number. Now 600 students that are entering. So we would take 600 times 7 over 10. Now we could put the 600 over 1. Now we could do the prime factorization. Now watch this. We know the prime factorization of 100 is 2 times 2 times 5 times 5. That's our prime factorization of 100. But we know 100 times 6 give us 600. So what we need to multiply in is a 2 times 3. So these 2 2s and 2 5s is 100 times 2 times 3 will give us 600. And we multiply this by 7. Our denominator, we could do the prime factorization of 10, which is 2 times 5. These 2 simplify out, these 5 simplify out. Now we multiply. 2 times 5 is 10, times 2 is 20, times 3 is 60, times 7 is 420. And because everything simplified out in our denominator, that would be 1. So it'll end up being 420 divided by 1, which is 420. So 420 is your final answer here. Now we scroll down. We look at 26. It says a 72-inch board needs to be cut into pieces that are 4 4/5 inches long. How many pieces can be made? This is a division problem. We want to take this 72-inch board and divide it into pieces that are 4 4/5. And we want to know how many pieces can be made. So this is what we would do. This would become 72 over 1 divided by, we'll take this mixed number and make it into an improper fraction. This would give us 24 over 5. So now we would keep this first fraction the same. Division becomes multiplication, and we take the reciprocal or flip the second fraction. Now we take the prime factorization of our numerator. The prime factorization of 72, we know is 8 times 9, so it'll be 3 2s for the 8 and 2 3s for the 9. That's our prime factorization of 72. Now we have 5. 5 is already prime, so we carry that over. Now we don't have to carry over this 1, but we do need to do the 24. There's an 8 times 3. So we know 8 breaks down to 3 2s, and we know 3 is already prime. That is our prime factorization of 24. Now we simplify out what we have in common. We add 3 2s on the top or in the numerator, and 3 2's in our denominator that are the same. And we have this set of 3's that are the same as well. So we're left with in our numerator 15 and our denominator is 1. So it'll be 15 pieces. Because remember, we never leave a fraction divided by 1. So our final answer here is 15 pieces. Now we scroll down here to problem 27. It says, Leah wants to make a half batch of cookies. A full batch uses 2 1/4 cups of flour. How much flour should she use? Now remember, a full batch is 2 1/4. Now, she wants to do half of a batch. So we will multiply this by 1/2. So we need to take this mixed number and make it into an improper fraction. So this will give us 9/4 times 1/2. So we would do 9 times 1, which is 9, and 4 times 2, which is 8. 9 and 8 has nothing in common. But remember, since we started this problem off as a mixed number, if we could make this into a mixed number, we're supposed to. So we would take 8 into 9. 8 goes into 9 one time. 1 times 8 is 8. And then we have a remainder of 1. So our integer would be 1. Our denominator would be 8. And our numerator here would be the remainder, which is 1. So it's 1 1/8 cup. And that is our final answer. Now, I'm going to go on to problem number 28. So, what we have here is we have the decimals. So we're going to add these decimals. We first must line them up. So, we're going to line them up vertically. So we have 43.2. And now we have to line up these decimals. 0 is in the ones place. We have our decimal. 3 is in the tenths place. And 5 is in the hundredths place. And then here we'll put our plus. We'll put our decimal. 9 is in the ones place. And 8 is in the tenths place. Now we're going to add them. We can add zeros here as placeholders. So we will have just as many numbers behind the decimal. Now we add 0 plus 5 plus 0 is 5. 2 plus 3 is 5. Plus 8 is 13. Write down your 3. Bring down your decimal. If it'll let me write the decimal here. And then carry the 1. 1 plus 3 is 4. Plus 0 is 4. Plus 9 is 13. Carry our 1. 9 plus 4 is 13. Plus 1 is 14. So our final answer is 143.35. Now we look at number 29. We have 6.45 plus a negative 7.8. This is the same as saying 6.45 minus 7.8. Now we know we're going to subtract these. Now if we look here, our answer is going to be negative because we know 7.8 is larger than 6.45. So we could write this up as a regular subtraction problem, knowing that we're going to have a negative answer. So we'll put our minus sign here and a 0 here. Now remember, our final answer is going to be negative. So now we have to borrow 1 from the 8 here and make this 0 a 10, as we cannot subtract 5 from 0. So we add 10 minus 5, which is 5. 7 minus 4, which is 3. Bring down our decimal. And then 7 minus 6 is 1. So our final answer is 1.35. We still line this up like we would do the addition problem, the decimals and the place values, and also vertical. We align this up vertically. 15 we know is assumed to have a decimal behind the 5. Then we have 3.45. And subtract. We can add 2 zeros here. Now we know we cannot borrow from these zeros, so we'll go over to the 5. This would become 4. This 0 would be 9. And this 0 would be 10. Because actually we would carry the 1 here, that's 10. And then borrow 1 from that, that would give us 9. And this would be 10. So we add 10 minus 5, which is 5. 9 minus 4 is 5. Put our decimal. 4 minus 3 is 1. And we bring down our 1. So we have 11.55. And that is it for problem number 30.